All right, so I've got that recording, and we're gonna do. All right, so we're gonna do some notes today. Let me just give you an outline of what today looks like, and then we'll get started. I will say we will have a chunk of time at the end of class today to kind of reconvene and make sure everyone's feeling good about stuff. We're gonna do a short schedule / assessments talk. Today's the last. Well, we only have 2 classes together. Today's the last thing last time we are learning anything in the year 2021.
Whoa, okay.
And it's actually kind of, we're finishing unit 5, so we're like halfway through our material, so that's pretty cool. And we're going to be doing something called Euler's method today. Today is really easy. I'm not like trying to trick you. Today's lesson is easy. It's repetitive, so we're going to do the same types of questions over and over. And I'm going to just show you the ways that I can make it hard. I'm going to give you the option to do a notes check today. Not the option. You're going to have to do at least 1 notes check today. But if you want some extra practice, you can do up to 3. I'll explain that later today. And then at the end of class today, you're going to just have some work time because what is happening next class? Test, but why are we not scared? There's 3 reasons not to be scared.
Partner test?
Partner test.
Online?
The test, I have a copy for you today. It's the exact test minus I reserve the right to change the order of the matching.
Whoa there.
And I reserve the right to change like an 8 to a 10.
That's messed up.
I probably won't do that with too many questions, but I just want to make sure we know how to do things. Also, reason number 3, if you were a fan of the mastery test where I checked it off as you went, I'm also willing to do that. The only thing I am not willing to do this time is let you choose your partners. I will be choosing your partners for you. For complete transparency, the way I like to choose partners, and I promise this is the way that works the best for everyone. I've tried many ways over the years. Is I will print out a list of all of your grades, probably from first quarter, something that's been finalized.
What?
The people with the top 2 grades will get paired together. Numbers 3 and 4 will get paired together, 5 and 6. Now that sounds like it's unfair. It makes for better conversations between everyone. I promise. But just for full transparency, that's probably how the partners are doing it.
Lowest and highest grade.
I also want, when I do that, also a purpose of that is to get you working with someone you might not sit next to, because usually it mixes up people a little bit. So I'm going to be helpful next time. Really the purpose is just, I want to finish unit 5 before we go to break. There's no sense in extending it.
All right, Johnny, I get
You have the test.
I get one of the people from the back. Oh my gosh, go. I get Emily or something. Let's go. Anybody got a net?
All right, so very clear. Hello. Hi. Class still happening. Okay. You guys are on it. I'm listening in front of you. It's actually kind of reversed.
Wait, did you say quarter 1?
Class is exactly
Did you say quarter 1 or quarter 2?
What?
Quarter 1?
Probably quarter 1 is the final one. Yeah.
That's why we do it.
I put it in. Oh, sorry. Grading stuff right now. All right, so just to be clear, here are the 3 things. They're not in order. I apologize. They are in the order that I thought about them. So here are the 3 things that I'm trying to do before break. The test is next class. That is not an optional experience. Everyone will experience that next class unless we're talking and making an alternate plan. Some of you that have been asked a lot will make a plan. The notes check that we do today, you'll have a choice of which one to do. Most people chose the one from today because the notes are going to be really easy. That's due by the end of class, 2 questions, super easy. If you are choosing to do the problem set, that is an optional experience. I just want that before break, so before like 4 o'clock on Friday. I will be heading out pretty early on Friday because I got to make it to somewhere by 4:30. So don't like run by at like 4:20. I won't be here. But if you could try to get that to me, that would be great.
So for the test review, are we allowed to get that checked?
Yeah, absolutely. So the only thing about that test review, so it is the test minus switching the order of matching, maybe switching like one constant here or there. You're more than welcome to ask questions either in the morning via email, whatever you want. I'm more than happy to help you with it. That's totally fine. I won't post an answer key, and one thing that will impact is when you come to take the assessment on Thursday, we're gonna put phones up around on this board just so that I collect them, so I know no one has pictures of them looking at.
True.
That will be the only thing. I know you guys haven't done that yet this year just because it's hard for me to adjust between classes, but that will happen.
What, cheating or?
Yeah, the partner assessment where I check off stuff is a little hard for me to manage and like pay attention to what everyone's doing at once. So the phone management will just make it easier for me to help and make sure I'm not like stressing. I promise I won't take your phone. All right, any other questions? All right, then let's talk about this beautiful man. Nate.
When will the assignments, like, when will you know by?
When will I know what?
When we were paired.
When we're paired, who the pairs are, as soon as I see who is in class on Thursday. Because if someone's absent, that affects. Everyone's gonna be fine.
The two lowest grades compared to.
I also don't want to tell you right now because what I don't want you to do is be like, oh, Nate, I'm paired with Nina. Nina, you study 10 through 5. 10 through 5. You study the second 2 pages of the test, I'll study the first 2 pages. I don't want that. I want everyone to be prepared for the whole test.
Are you gonna show us the grades here?
No.
Yeah.
No, not at all. All right, so let's look at this beautiful man. Yes, Miss Jillian. Yeah, so that's why the test is pretty darn short. We'll have about 50 to 55 minutes to take the test. If I am correct, so it's about 5 minutes per question. Should be generous enough. All right, so let's talk about this wonderful man right here. I'm not really sure. I think it's an attempt at a turban. I'm pretty sure he went blind later in his life, so it might be at that point. Oh, look at this debonair pic over here. Does anyone know who this mathematician? Yeah. I know. We kind of got distracted. All right. Has anyone heard of this man before? His name is Leonard Euler. His name is not Euler. It is Euler. He is probably the most prolific mathematician of all time, meaning he has the most stuff done in mathematics. To the point where if everything that he did actually got named after him, like half of math would be named after Euler. He is the only mathematician to have 2 constants named after him, one of which is E for Euler. There's another one, but I forget what it is. This equation is called Euler's identity. It's probably the most beautiful thing in all of mathematics. If you care, if you are enthused at all, we'll be able to prove it later this year using Taylor series, which is kind of fun. We'll watch a video that the Khan Academy guy does. Essentially, the Khan Academy guy says if you look at this and like don't think it's beautiful, like you don't have feelings. So this is our E, our complex, our imaginary number I, pi from circles, plus 1, our multiplicative identity equals 0, our additive identity. It's like all the important numbers in math in one equation. It's beautiful. If you want to hear me excited about math, just ask me about that. It's wonderful. And the way to prove it involves sine and cosine. It's literally wonderful. So Euler did a lot of things, but one of the things he did is something we're going to do today called Euler's method. I'm going to give a brief synopsis of what it is, and then we're going to talk about it. Doing this process is super easy. Euler's method is essentially, see that like rainbow line underneath, the rainbow like jagged thing? That is what Euler's method is. So a lot of our differential equations are not ones that we're going to be able to solve. So what Euler's method does is it gives us a way to approximate what a solution is doing. How it's going to do that is it's going to use lines, tangent lines essentially, to approximate kind of in steps as we go. So it's going to write a tangent line, it's going to reevaluate and write a new one and a new one in certain amounts of steps. Now, we're not going to do very many steps because this process is what I would call iterative. It does iterations, so it does this process over and over. So it gets really tedious and really boring. So we'll probably do like 2 to 4 steps today, and that's about it. So let's do this. No staple notes. Woohoo.
One page?
Wow. I think 1, 2, 6 problems.
Yeah.
Oh, wait. You guys aren't SBA. What am I supposed to wear on Thursday? I don't understand. Yeah, what does that mean?
Like,
Yeah,
can we have like sparkly stuff?
We're like a party act.
2007.
I'm in the room.
I mean,
How do I, he doesn't appear. Like, I'm in his room.
tomorrow is Santa's workshop. That's my favorite one. I made something like 5 years ago.
Yeah, I walked in the old lady came to there. All right. All right, so the stuff at the top is really just some informational stuff. I want to show you a couple of things about it, but this is really going to make more sense once we start doing questions. So please don't get angry until after the first full example that you don't understand. So I would like to show you that a lot of this notation is really just a tangent line. So what we're going to be doing to find our new y value, we're going to be taking our y value and approximating new y values, is we're going to be taking our old y value, so our y value from our previous step, adding our derivative evaluated at the x and y from the previous step times our step size. So it's going to give us like a slope and a certain amount of part to go over to approximate what the new y value is doing. Now that formula comes from a tangent line, so I'm going to move this f of x over really quick just to show you that. If I subtract f of x here, and I'm going to write h a really weird way. I'm going to write x plus h minus x. This is really just a tangent line because I have a y value minus another y value. So like y minus y1, our slope, which is x prime, and then two x values being subtracted. So like our x minus x1. So really just to emphasize, this is all based on tangent lines, but I'm really going to lean into this idea of the notation in words. Essentially, I'm taking whatever y value I used in the step before and using my slope and how far I'm going in the x direction to approximate a change in y. This process is going to feel really repetitive, and the nice part is the directions are pretty straightforward. So you're not going to have to guess when to use Euler's method. They're going to straight up tell you. So let's look at an example and kind of follow through. So we have that f of x is a particular solution to my differential equation. Now, this is a differential equation that we could solve using our methods from 2 classes ago, because we could separate these variables. How would you guys separate this one? What's on the wrong side? Okay, we can move the dx to the right. What would we have to move to the left? The y. We could divide by y. Now, this one is not asking us to do that because of the words that are coming later. We do have this initial condition, f of 0 equals 3. That's usually the first thing I'll write down because it's my first reference point on this graph. Now, notice the last sentence, super straightforward. They're saying use Euler's method, starting at x equals 0, convenient. That's the one point I have on this graph. Tells me the step size. So I'm going to do a step size of 0.1 to approximate f of 0.2. So how many steps am I going to take? 2. So I'm going to make it to f of 0.1 and then f of 0.2. Now I'm going to start using the curly equal signs after that because both of these are going to be approximations. What I'm going to do is going to take me close to where this curve is going, the solution curve that I'm not finding. But it's not going to take me quite there. I'm going to be a little bit off, and I'm going to deal with that. So let's find f of 0.1's approximation. I'm going to start by taking what I would call the old y value, meaning the y value from the previous step right above, which is this 3. Now, I want to plug in my previous point, 0, 3, into my derivative equation. Does anyone see a derivative equation anywhere? Yeah, it's our differential equation. So we're going to plug in to this guy. So I'm going to do 0 times 3 all over 2. So notice I am using the 0, 3 from the step before and not the x value from f of 0.1. Everything's coming from the step before. So very computer sciencey where everything's coming from like the step before and you're using in this step. The last thing I'm going to multiply by is the step size, which in this case was given to me, that's 0.1. One iteration done. We do want to simplify in this case, but what's nice about the second term here? Yeah, this whole thing is 0 because that nice 0 right there. Now, will the first one always be exactly the same? Will I get 0? No. So that's just in this case, all of that 0 times 0.1 still 0, so I get 3. No. So good notice. So Emery's noticing that I went from curly to equals. F of 0.1 is approximately equal to this, but these numbers are actually equal to these ones, so that's why I'm swapping. Would they be picky if you messed it up on the AP exam? No, that's way too picky. Yeah. Cool. Yes. Oh, look. Look who's on my water bottle. If anyone knows Zara Ashford, she got me this sticker last year. And now she's at Yale. Yeah, she's brilliant. And just really great at everything. All right. So now we're going to find an approximation for f of 0.2. Now I'm going to use the x value and the y value from this step now. So I'm done with this guy. I'm now using 0.1 for my x and this 3 for my y. So my old y value is 3. I'm still going to be using the derivative equation that I was given in my problem, my differential equation, but I have 0.1 times 3 divided by 2. My step size is still 0.1. So one thing you're going to notice is every single time this number will remain the same throughout the problem because we're going to be taking equal steps for our Euler's method every time. So that's kind of convenient. Now, the point of this is really to be able to do this without a calculator. So sometimes one of the hardest parts of these questions is evaluating the arithmetic. So to help you practice, take about a minute, and I want you to decide, without the use of a calculator, what is this equivalent to? So these 3 points. So here, my x and my y are coming from this step now. So my x and my y. So it's a lot like computer science where you're like referencing stuff.
1.5 times what?
Yeah.
No, this is backwards.
Probably not.
Oh, a tenth of that.
Yeah. Zero. This is 0.
Yeah, you go one step further.
Yeah.
No.
A tenth of.
0.5.
It's like a tenth of 50.
All right, anyone got a number?
3.0.
Does anyone agree with Rashad? Perfect.
Yeah, I did a lot of practice.
All right. Here's personally how I thought about it. If you would like a way to think about it and you were unsuccessful, I focused on the numbers I could divide. So 3 divided by 2 I knew was 1.5. And then each of these 0.1s is going to move my decimal one place to the left. So I had 1.5, 0.15, 0.015, and then added it to 3. All right. And that's really it. That's about as hard as I can make this question. So we're going to try one more that's super straightforward, just like what we did. We're going to work with fractions instead of decimals just to give it a little bit of a spice. And then what we're going to do is try to do this problem in a little bit more of an AP style where it's going to ask it a little bit backwards. I'll do one, you'll do one, and then we'll take our break for today. So how old were you in 2007?
3, 5, baby.
Cool. Fun fact, I was a junior in high school, probably sitting in room 253. And excellent. Getting old. So this was a real AP test question, albeit a little bit long ago. So we'll look at some kind of more relevant ones in a second. I would like to point out, since this was number 5, that meant it was a non-calculator question. So we're going to go through and simplify the whole answer, but I'll kind of show you where you could stop if you were taking this on an AP exam. So let's read through, and we're going to kind of look for our important pieces of information.
Could you stop with the before the simplification?
So I'll show you where you can stop here. So f of x is again a particular solution. One of the biggest things I want you to realize from these directions is just because we see the words particular solution doesn't mean we need to solve the differential equation. And in fact, this differential equation is not one we can solve because there's no way I could like multiply or divide y to get it only over to this side. I would have to like subtract. It just wouldn't work to separate in the ways that we know how to separate our variables. This is actually one we will not learn how to do this differential equation this year. I believe it's a first order differential equation. So if you took like a DiffEq class in college, you would solve something like this.
Has the whole class just from
Differential equations, there's multiple classes. So there's ordinary differential equations where you could solve something like this. There's partial differential equations. Some people study differential equations like for their life.
Really?
Yeah, because a lot of them are very hard to solve. So I think this one, if I remember, needs something called an integrating factor. So there's like e's all over the place. It's pretty cool. Well, if you think about differential equations, that's a rate of change. So like my sister uses a lot of differential equations in her work in ecology because she's talking about the rate of change of plant growth, the population growth. You could probably model a lot of rates of change this way. All right, so let's look for our important pieces of information. The first one I see is this point. Again, I like to start by copying this down because it's going to be the first step in my process. Again, they're being very verbal about me using Euler's method. This is not a guessing situation. I'm going to know that I have to use it. I'm starting at 0. No surprise. It's the only point that I have. I have my step size is 1/2, and I want to approximate f of 1. How many steps am I taking? 2. Again, we are, I think, the only ones I've seen on the AP test ask for 2 or 3 steps, or even 1 in some cases. We're going to do one today that has 4, and it's going to become pretty obnoxious by the end. It really, you're not testing anymore at that point. Yes.
And then you write the 1. Are you writing the 1 because that's plus another 1/2?
Yes, exactly. Yep. So what Nina's saying, I went from 0 to 1/2, and then I'm saying 1/2 to 1 because I added another 1/2 for my step size. So it's like my counter, kind of like if you remember delta x in Riemann sums, how I counted by that every time. Sorry, just trying to connect back. You're just counting by that much. All right, let's go ahead and do f of 1/2. So how does this go again? Did anyone remember at this point? All right, -2.
plus 3 times 0?
All right, I'm going to plug in, just to be really verbal about this, I'm going here and I'm plugging in my x and y. I like that I'm hearing 0 and not 1/2. We're using the x value from the previous step. So 0 plus 2 times the y value is still that -2 plus 1. What am I missing?
0.5.
All right, I'm going to multiply by 1/2 for my step size. Just to give a new kind of format to this question, I'm going to work in fractions in this question, but if you're more comfortable in decimals, anything mathematically equivalent is fine. Like I said, that this is a non-calculator question. I would recommend in this step, even though this is a non-calculator question, since I'm going to have to use this value in the next step, I would personally simplify this as long as I'm like pretty brave about my arithmetic. So this is a time, since I'm going to use this in my next step, I'm going to be really careful about my arithmetic. All right, this goes away. So I've got -4 plus 1 is -3 halves. All right, that's -4 halves minus 3 halves. So I think -7 halves. We good? We good.
Wait, I could make
That is the same thing, because 7 divided by 2 is 2.5. All right, so good example. Nina likes decimals more. Nina can use decimals. Okay.
I don't know why it's
In this moment, Nina decided decimals were her jam, so she's going there. All right, so now we're going to go and find f of 1, or our approximation for it, to be more accurate in my verbiage. What's the first number I'm going to write down? -7 halves, or -3.5. So I'm using the y value from the previous step. I am going to use this derivative again. What x value will I be using? 1/2. I want to use the one from the previous step, plus 2 times -7 halves, plus 1 times my step size, which is still 1/2. We're doing equal step sizes every time. Now, if this were a real AP test, I would not touch any of this. At this point, I am done with this problem because I've been asked to approximate f of 1. I have an approximation for f of 1, so I would actually stop. If you wanted to be really obnoxious and make your reader really mad, theoretically, you could use this entire thing in this place and this place if you were willing to write and didn't want to simplify that much. I would say you'd probably make a mistake writing it down. So I think simplifying into the middle step is probably worth it, but simplifying from here isn't. How much time would that waste? I think more than actually just simplifying it. So, I don't know. All right, for the sake of argument, though, let's simplify the fractions together just to make sure we know how to do it in case this were a multiple choice question. Looking at the innards of this set of parentheses with the derivative inside, anything you guys would cancel? Would anyone cancel these 2's? I personally would. Let's see if we can simplify. Did anyone do it already? Or just me yesterday? All right, let's see. I got 3 halves plus 1. Oh, -7 plus 1, -6. All right, all right. So I got -7 halves. 3 halves minus 12 halves is -9 halves. What's wrong? Why did I write 14? 4. 14 minus 9. Yeah. All right, does everyone know what I'm doing? Or am I just up here by myself? All right, so choices I'm making. Everyone just stop talking. All right, so simplifying from here. I got 3 halves is from the 3 times 1/2. -7 plus 1 is a -6. 1/2 is still inside. This is 3 halves minus 12 halves, so that is my -9 halves. Just cut this guy. And then I thought I was going to get fourths, so that was going to be 9 fourths. Where's the 14 from?
-7.
Yeah, -7 over 2 is the same thing as -14 over 4. All right, now, so why did I simplify that? That is math that I think both the AP and I would feel very comfortable putting on something like a multiple choice where you would have to get to this answer. Will it happen all the time? No, but should we be comfortable with that arithmetic? Probably. You could. I personally don't like working in fourths very much for decimals, but that's more of a personal choice, so up to you. All right, I would like to do one question for you and then have you do one question for me. Sorry, not sorry, the version I'm doing is much easier than the one I'm going to ask you to do, but we'll talk about why, and I think by the time you get to yours, it'll be pretty darn easy. So this is the way that I think we could make this Euler's method question a little bit more interesting. So now that we've done a couple of versions of just straightforward, I want to show you the ways, how could I make this less boring? The first way is to shove some constants in there. So we got g of x is another solution. Notice this is part B. So we're still dealing with this dy dx equals 3x plus 2y plus 1. Initial condition, g of 0 equals k. Da, da, da. So a little bit spicy. We got a constant in here. What did I say that one time? Let's get wild.
Yeah.
Let's get wild. All right. Wow, it didn't say using. I'm just making so many typos. Using Euler's, just Euler's method, comma. Oh no, that is right. Euler's method, starting at x equals 0 with a step size of 1, gives the approximation g of 1 is approximately 0. So we're saying we did Euler's method with a step size of 1, and we got the approximation 0. So just like in the last question, I could have said using a step size of 1/2, and for f of 1, we got negative 23 over 4. I want to find the value of k. How many steps am I going to have to make to do this question? Just one. The one I'm going to ask you to do, how many do you think you're going to do? Two. Amazing. Wow. All right, so I'm going to do one. I'm just going to not freak out about the k. So what is my old y value? K. That's fine. All right, my differential equation from the last question is still happening. So 3x plus 2y plus 1. Speaking of x, what value am I using for x? 0, the one from the previous question, line of work. 2y, what's my, Nazi? We're going to get there in a second. So it's saying that like after the first step, I got that number. So if from the previous question, it would have been negative 7. All right, y value, what am I plugging in for y? Okay, 1 is still himself, and my step size was? Oh, convenient. All right, so here's where I'm about to use this approximation that I circled that Nazi was asking about. So they're saying after one step, they got the number 0. So all of this stuff is equal to 0. Now, if you're like me, you're probably very excited. Because if you look, this equation has numbers and k's, and I've got equals 0, which is a number. So the only variable left over is just k. I can solve for it. So I've got a k here and 2 k's here. We're distributing a 1, so I don't really have to worry about it. I got 3 k's total. This is 0, so I've got plus 1 equals 0. Oh my goodness, my Algebra 1 students can solve that. It's negative 1/3. So let's see who's been listening and who can do some arithmetic. So like I said, the version you're about to do is definitely a little bit harder because you're going to have to do 2 steps. Notice a step size of 1 to get from 1 to 3. You're going to have to do it twice. So what I want you to do after your first step, don't set it equal to anything. Your first step, you got no information about. You're going to take whatever that thing is. It's probably going to still have k's in it and move to the second step. I want you guys to try to do this. Once everyone's got it, we will take a break.
So only 2 steps because we're starting at 1.
So we're starting at 1. You'll have an approximation for m of 2. Do not, well, pass go. Do not click to it, whatever. Just go straight to m of 2. The middle. I used the same differential equation from before. This is part B of the same problem.
Oh,
So I did 3 times x is 0, 2.
yeah.
Okay. Yeah. All right. Goal 4 minutes. So like don't set your m of 2 equal to anything. Use that to immediately find your m of 3. So you have to find the m of 2 first. Yes, your final number should be Right, so this is now like your old y value for your next step. So like where that 3 is, you're gonna put that in your next step. So 5 is going to be equal to whatever you get in the next step. So I would actually wait for that 5 until you write out your whole line. All right, be careful. This 5 is what is here. This, yeah, this is what goes in.
Where you kind of X is not bad. X is
The case is still a variable.
right. So you're not obviously by where are you trying to what do you got shot? I got 4. I got negative. It may be negative 4. No, I don't think it's negative 4.
2k plus 2k is 4. 2k times 2k is 4k squared. Oh, guys. That's not. 2k times 2k is 4k squared.
All right, so the biggest mistake I'm seeing is people are just trying to replicate the last question. So you should have gotten, with everyone getting 2k plus 13, that seems relatively good. So we have to make another step. So we are immediately going to take that and treat it like our old y value and continue on. Once you get that step, you're going to set it equal to something. I'm going to let you continue on for a couple of seconds. You should get a very nice number as your answer.
Oh, plus older. Oh. Plus number? Oh, we're fine. No, we are multiplying. So in the middle, I thought you were multiplying for 19. Oh, you're not. 4k plus that does not sound like me. Plus 39.
Oh, because you made it.
10k. 12k plus 54 equals what? 3 times 13 is 39. Oh, plus 1?
Plus 40 plus 30 53. 2k plus 10k is 12k.
And okay, 53.
Negative.
What? Oh, I give it. Wait, that's so. Okay, the base 48k.
Super nice number. That one. Very nice interpretation of negative one.
Oh my god. Nasty. I know what Sean has. Listen.
Is it okay if I did it the other way like this?
Yeah, that's fine. He said, no. It's fine.
Light refractor.
It's not light. Oh, it's light refreshments this year? They're not doing the whole dinner this year? Rude.
You don't have to watch it, guys. I'm sorry.
That's really rude. It's usually a whole dinner. It's like a good. I'm gonna say it's actually a pretty good dinner too.
I mean, I can cook better, but I mean,
What teacher are you inviting? Such a fun time. Are they only doing one of them, or are they doing two? Do you know how much they're breaking it up? Is it here?
I think it's just the school.
Oh.
I didn't even realize
The dinner is really boring. It's like 3 hours of listening to them read names.
That's why,
It's
I don't want to
like it's fun. It's really fun, but it's also kind of the worst.
I don't want to speak, but I feel like it'd be disrespectful to my teacher if I didn't speak.
Mm-hmm. My GPA doesn't really make sense because it was really different. Like 4.46 or something like that. I got all A pluses except one A, and I took 8 AP classes.
Not this year. Yeah, not this year.
No, like total. I'll be 5 my senior year. So like 1 sophomore year, 2 junior year, 5 senior. It's like a relatively normal schedule. I would say you guys would all crush me because you take way more AP classes.
You could take freedom to take the classes you want to take, right?
Yeah, I mean I took choir all 4 years.
What was your class rank?
1, bro. Oh, wait, your sister technically won?
I would say I tied for first. My sister did not tie, so she likes to remind me that she's the real valedictorian in the family. Because she got just 1 and didn't tie. UVA. No. No, there's just no 2. So 1, 1, 3. Gold, bronze. What? Oh, I got named teacher of the month for November. My dad went there and currently works there. And I used to work there too. I worked in admissions for a little bit. All right, so we all good with -4? Does anyone want me to explain this at all? All right. Biggest mistake that I was seeing as I walked around is mostly just people were trying to stop at this step and do something that makes sense because that's what we did in the previous question. But other mistake I was seeing, make sure you have old y value. This is my old y value multiplied by 3 from this 3 right here. This guy, a lot of people are trying to use the 3 from the x. Again, we need to use the previous value. So whatever you need to do if you want to write the point that you're using right here, and then it's just arithmetic. So we're going to take a short break right here. When we come back, the only other way I can make this interesting is just to present you with material in a different way. So I'm going to present you with some material in a graph and with a table just to interact with different representations of functions. That tends to be a trend right now in the AP test, is just to give you something that's not just straight up like, hey, this is what dy dx is. Let me give you something more interesting to look at. So we'll do those two. It's going to be very similar though. And we'll be done for today. So take a break, and I'll come back with those two questions. Then we'll be done with notes. Okay.
Miss Sophie, did you take the SAT for college?
Yes.
What'd you get if you don't mind?
Super score? God, I don't even remember now. Do you want just out of 1600?
Yeah.
Oh, because
Yeah, they converted it, right?
I would say we were in the weird years where you took the writings, the 2400 scores, or no, it was, I don't remember. I think I was slightly north of 700 on both reading and math.
Oh.
In like,
Oh, but it was harder than
I don't think so.
Yes?
I'm like, I don't know about the SAT. I only took it twice. I didn't. Honestly, I would have if they didn't say like, oh, you should take it twice because you'll do better the second time.
Yeah.
I did worse, but that's okay.
I think I did worse in math, but like better in reading.
That's
So
what
my
I did.
super score got better.
Yeah. Okay, so I went to a tutor on Sunday, and I told her that we were talking about Euler's method.
Yeah.
And so we like went over it.
Okay.
Taught me how to do like this little chart thing.
Yes.
If I do that like on a test, will that
As long as you label the top of it, I am totally cool with that.
Okay.
The problem with making the chart, and I've seen over the years, my students stopped labeling it after a while. So I
okay.
was like, you know what? It's just going to be easier to write it this way.
Okay.
As long as you label it, I am totally cool with
Okay.
that.
Thank you.
Hello.
Is that right?
No.
Okay, great. What am I doing wrong? So when you do f of 2, do you use the previous y value? So you use the previous x value over here? Do you use
I don't like this negative one. How'd you get the negative one?
0? Wait, sorry, -2.
Which is unfortunate because then that changes everything going down.
Yep, it does.
Yeah. This is a very good question to be very careful on. These are the dimmest they can go. Without turning it off. I would -90? I might have messed it up. All right, whatever. Let's just do it. I would change with this, so keep this top one, change this multiplication, and multiply by the reciprocal instead. And then I would start focusing on that.
That makes it worse, man. Hey. You're going straight down, man. Hey, it was.
I'm doing that.
I don't know why they did that. And I didn't. I was just minding my own. Huh?
Yes, I'll make a comment about that one. Hello. Why is everyone doing math during our break? What is this? I didn't get that either. How are you doing this? -4. Where's your step size? Where's your step size? 1/2, 1/2, 1/2. Here, we didn't need it. 1. Not 1. 2. Yes. What? Probably not. I'm gonna make you guys talk to girls.
99. Please don't pair These guys don't know.
You can choose to fly solo if you want. That was the question. No.
Wait, people got 100 in this class this quarter.
Yeah.
I'll figure out this too.
I would say like 2/3 of my students probably have A's, most likely. In a normal year, maybe not right now. This year is not normal. But I'll use what? Is not normal. All right, let's go ahead. I would love to stop teaching for the year 2021. So I'm going to do these last two problems. I think these are more fun. Just because, like, doesn't everyone love to look at a graph or a table or something? So I'm going to look at this one. We've got f of x still a particular solution to this differential equation, but let's get wild. We have h of x inside dy dx. Since this graph is not labeled, normally they would be on the AP test, but since it's not, I'm just going to label it to make sure I remember what graph I'm looking at. Initial condition, we got f of -2 is -4. Yeah, this is not hard. And h of x is on the picture using Euler's method, starting at x equals -2. 3 equals steps. Okay, so that's kind of annoying. I gotta get to 4. Oh, wait, what's missing? They didn't tell us what the step size was. Yeah, we got to figure it out on our own. So we need to go in 3 steps. We need to make it from -2 all the way up to 4. 0 to 4. Well, that works. We could also take the distance between, so kind of like we found delta x back way when we did Riemann sums. You could do like a b minus a over number of steps situation. So 4 minus -2 to get the distance between those. That's 6 divided by 3. Because I made a mistake. No, that's good. I kept forgetting to write them in my notes, so thank you for that. All right, so let's start the first one, and maybe I'll let you guys roll with the next couple. So first number I'm going to write down. -4. All right, my old y value. Now, my derivative is where it's going to get a little bit interesting. What you're probably noticing with these problems is it's very important to be focused on accuracy, because if I mess up at f of 0, that's going to impact f of 4, which is going to impact, f of 2, which is going to impact f of 4. So you want to be really careful, because if you mess up in the first step, then I have to rework your problem with your numbers, and I'm not going to be happy. So make me happy. All right. 2 times, what's my x value I'm using? -2 from the previous step. Plus, and I'm just going to write h of -2 for a second. I'm going to let myself ponder. And I don't want to drop the thing on the end. What was the step size that we found? 2. This gets forgotten a lot, that step size at the end, so don't forget him. Yes. So I looked at, I think most people just did it kind of in their head. We were thinking -2 up to 4 in 3 steps. So to start counting by something, but you could think of like the distance between these two is 6, like a 4 minus -2, and I want 3 steps. Most of the time they're going to be nice numbers. All right, so I got -4. I'm not going to drop that plus. What is h of -2? 1. For this graph, I'm just looking at the y value, but you could think of how I could integrate different topics into this. So I could ask for like h prime of -2, and you could look for the slope of that graph. I could ask for an integral and make you do area on that graph. So there's a lot of opportunities to shove different topics together, which I think is really interesting. Yeah, absolutely. I'm just being really careful in this case, mostly because I was afraid of making a mistake. As long as I could do it in my head, they're probably fine with it, and they're smarter than me. So as long as you're not taking steps in your head that like a normal person wouldn't take in their head, it's fine. I like to show my work a lot. All right, -10. Is that kosher? All right, you guys want to try the next 2 steps? All right, I'm going to take a lap around the room. You are now using the point 0, -10 in this next step. Oh, you just done? Okay, this one's a yeah, a lot of the time I did it
Times 2.
and then I did it back.
I'll go for the circle. Next one.
Yes.
H equals 0 is
Two of them were two. Six.
Yes. All right, I'm gonna start writing up my work. So erase me, see if you can finish before I am done. You shouldn't.
4 plus negative 1, 3 times 2 is 6 plus negative 1.
Oh, so I did the math wrong. Okay. 4 plus negative 1. Oh, positive 3.
Minus 3,
Can't do this.
plus negative 1.
What?
My brother says he had a t-shirt because there's no minus, it's just negative. He'll do plus negative.
Yeah, I've heard that before too.
Yeah.
And like, there's no such thing as dividing, it's just multiplying by fractions.
Yeah.
I mean, sure.
Like, stop
They're a little extra sometimes.
Bro.
All right, I believe, I don't want to spoil it, but I believe the answer that I have is highlighted in blue if you would like to view it. I'm getting some thumbs up. Yeah. So if anything, I would like to recommend when doing Euler's method, this is the place to be careful. We're going to do one last question, but really every step you're doing impacts the next step in kind of a very wild way. And in a very frustrating way. You can imagine if we get steps, and some of you might have made mistakes on this one, but if we're solving for K, little mistakes in our arithmetic can create a very weird value of K. Like I made a typo on my test last year, and the end result ended up being in like 49ths because any fractions kind of compound on themselves. I was sassed repeatedly about my mistake. So just be careful.
Can we all the same secret?
What?
Can people all the same secret?
I think so.
Can we all just be lucky a while?
Let's get one. I don't know if that one will get approved.
Yeah, probably not.
That's so funny.
I helped approve them last year. It was fun.
Oh, if you're approving of it.
All right, let's do this last one really quick. We'll do it all together. So we're talking g of x here. What is the first thing I'm gonna write down? You read the question for me.
Oh, okay. 2 equals 3.
All right. Did they give me the step size?
No, 4 steps.
Ooh, 4 steps, and I'm going to g of 0. This is very interesting.
Down 1/2.
I'm going down 1/2. So what do you think my step size is?
-0.5.
Negative 1/2. So just here to tell you, the step size is allowed to be negative. You guys want to work in decimals or fractions? I'm going to go decimal. Mostly because that's what I... Oh yeah, there already are decimals. You do whatever makes your heart happy, whatever sparks joy for you. Good question. So as we do this, Rashad asked a very good question. Did they give us the dy dx? In this case, they gave it to me in a table. They gave me the value of g prime, which is also a derivative. So looking at this, g of 1.5, taking the old y value, adding the old derivative times the step size, which is my negative 1/2 or my negative 0.5. I said I was working in decimals. So what value will I be putting in that box? I want g prime of what number? 2. I want the one from the step of 4. So I have 3 plus 4 times negative 0.5. That is 3 plus negative 2 or 1. All right, that 1 is traveling down to my next step. And then I'm doing g prime of what number? 1.5, using the stuff from the previous step every time. All right, 1 plus g prime of 1.5 is negative 6 times negative 0.5. That's 3 plus 1 is 4. You guys want to finish it out? All right, then finish my problem. You should get a whole number.
I'm down. So down.
It has to be reminded.
I can already hear you all saying, "Oh, that was the easy thing, right?" I'm getting excited for this AP exam. I'm feeling good about it. Why? You haven't even seen Taylor series yet.
Oh, okay. Oh, okay. Stay within the box. Within the box.
Yes.
Roll your eyes backwards real quick.
What?
Yeah.
All right. I believe the answer is on the board. So, as you probably could tell, 4 steps, that was a little tedious and annoying, yes? So, I believe the ones on the test that I put require 1, 2, or 3 steps. I can't really remember. There's one version where you're like finding a constant, like the thing on the top of the page, and one that's a little bit more straightforward. So I believe those are the 2 on there, unless I just lied to myself. So end of notes for today. We have 27 minutes left in class. So what are we gonna do with those 27 minutes? What a great idea. I would like to give you a little bit of a choice. So for the notes check, we've actually done 0 notes checks this unit, which I apologize. That's never my intent, but sometimes class just runs away from me. I have printed 3 notes checks for this unit. So since I have them on paper, I would like to give you the opportunity to practice with them if you would like. Most of my other class chose to do the 5.4. It's what we did today. So if you like that, you're more than welcome to try that one. I need you to do one of these by the end of today, but if you would like to do multiple for more points, you may. So 5.4 is one option. I'm gonna put all the options right here. Before you move, can everyone just stare at something in my general 12? 12. All right, other options. There's one from 5.1 that's like write the differential equation, determine whether something's a solution, and hey, here's a slope field. That one's pretty easy. If you want a challenge, this one's like solving differential equations and PERT. You are more than welcome to do 1, 2, or 3, but you must do at least 1 to turn in by the end of the block. One problem? 1 note check.
Oh, okay. Like, only have time. Wait.
Yeah, so I didn't make a note check for that one.
Oh,
Yes. Which one are you?
Multiple choice? Oh my God.
What's up?
You are missing
back?
No, back. I can give you another copy if you would like.
Oh, sure.
Oh, also, if you would like a paper copy of the test review, I'll give it to you when you turn in your notes check to me. Because I want you to do it.
Would you have to do all 3? It's just one, like,
Why?
are all 3 graded?
Yes.
Oh, so at some point we can do all 3.
No. Oh, if you choose to do them.
Get extra credit.
Oh, really?
Extra credit. Okay, so then my fault.
Oh, it's behind. It was in the last. Oh, two.
Oh, I guess I can stop recording now because we are just doing random stuff. All right, for anyone who's listening, goodbye.